Assalamualaikum. My name is Muhammad Fahmi Yusof. My matrix number is CE190029. And today I will I will explain the introduction of this project. So students should be able to comprehend the meaning of the intercept and slope from the simple linear regression model of a chosen problem using the statistical package of the social science SPSS software in this project. Students should collect 100 genuine data points, which in our group is the relationship between sound exposure and the time with average sound level. The report should primarily contain an independent variable x and a dependent variable y, where the independent variable x is the variable that the researcher change or controls and is expected to have a direct effect on the dependent variables. Independent variables are used to measure the dependent variable y, which is second type of variable. So that's all for introduction.
Okay, Assalamualaikum. My name is Muhammad Afiq Izzuddin bin Shahril. Okay, so today I will show the data. Okay, so here is the data from 1 to 100. Okay, and this is those percent noise exposure. And this is time width average sound level, TWA. Okay, according to this data, when those percent noise exposure increase, so the TWA also will be increased here. Alright, okay, start from first data. The dose or percent noise exposure start with 10 and TWA 73.4. Okay, so here is second. And the last data is 100. Those percent exposure for 90 and TWA is 101.5. Okay, so that's all about the data. Okay, so next I will pass to my group mates.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Abdul Malik Ahmed Muhammad Iskandar, and the manual calculation is my part of this presentation. First, manual calculation. For manual calculation, we need to know about the independent and dependent variables for our 100 data. First, the independent variables, which does our percentage of noise exposure, and the dependent variables, which noise in decibel. First, we have to deal with independent variables, which the percent noise exposure. But first, we have to find the mean for the independent variables x. Mean, it's equal total number of data over the total number of data, which we have to sum all the values for x and divide it by the number of the data. We will get 174.45 as a mean. Then second, we have to find the variance for the independent variables x. We will use this formula. So first we have to take the data and make a square for each of them, then sum all the data. We will get 4,633,215. Then for the standard deviation, we need to find the square of y. So we will use this equation, which the total for the data over 100, we will get 3043280.25. So to have the standard deviation square, we will have 4,633,215 minus 43280.25 divide by n minus 1. We will get 16059.94 697. For standard deviation, we have to take the root for this value. We will get 126.7278461. For the minimum value x equal 10, the minimum value in the table, and the maximum value which 419, which is the highest value for the independent variables. Second, dependent variables, noise and decibel. First, it has the same step. We will take the first, we will find the main dependent variables. We will use the same formula. Then we will get 9207.2. Then we will find the variance for dependent variables, which noise in decibel. So it has the same step. We will square for each data, then sum all the data. We will get 850805.2. Then we have to find the total value of summing all values, which we will get 9207.2. So to find the standard deviation, we need to first make it square, then divide it to 100. We will get 8,47725.3184. For standard division square, we will have the value sum of this equation minus the y square, which 8,47725.3184 divided by n minus 1, which 99. We will get 31.7179756. For standard division, we will take the root for this value, and this will be 126.7278461. For minimum value, the minimum value is the lowest value of the dependent variables, which 73.4, and maximum value is the highest value of the dependent variables, which 101.5. Thank you so much.
Okay, hi, my name is Zamir Ali bin Shahriman. My metric number is CE190028. So in this presentation, where I'll present about how to find the mean, standard deviation, minimum and maximum value for independent and dependent variable in SPSS software. So first of all, where we key in the 100 data for variable and independent and dependent variable, and then how to find the mean, standard deviation, minimum and maximum value, where we pick the analyze, and then we choose descriptive statistic. After that, we choose descriptive. So we insert two variable, which is noise and TWE, time wake average, and then we press OK. So as you can see here, there's a descriptive statistic data for noise and TWA of OSHA. So the dependent variable here is noise, while the dependent variable is TWA. So the minimum noise that we get is 10, with the minimum TWA is 73.40. It is classed as a normal level, which the noise from a normal conversation, while for the maximum noise, which is 490, maximum TWA is 101.50. It might caused by all of them have exposed to a loud sound. This means that volume noise exposed is 174.45, and the standard deviation is 126.72785, while mean value for TWA is 92.0720, and standard deviation is 5.63169. Okay, and then how to find the sketch diagram and regression line for the data. So to find the regression line and scatter diagram, where we pick the graph and then choose the chart builder, Okay, then we press OK, and then we pick the scatter mode, this one, and then we insert for the y-axis is TWA, time with average. For the x-axis is those noise exposed, and then we press OK. So as you can see here, this is a scatter diagram. Okay, to find the regression line, where we tick, double click, and then we press option. We choose element, and then pick fit line at total. Then we select the linear method. After that, we can close. So this is a regression line for TWA against noise. Okay, so this show that scatter diagram of TWA against noise exposed of OSHAR. So the relationship between noise and TWA is described by a linear function. The equation for regression line is 85.05 plus 0.0x. Thus, the graph we obtain is a linear relationship as all the data is near to each other and form a straight line increasingly. It can be concluded that the dose noise exposed increase, the time with average reading is increased. Hence, the change in TWA are assumed to be caused by change in time. So next, for assuming a linear relationship, use the least square method to find the simple linear regression model. Okay, then we back to the data. So to find the linear relationship, where we choose analyze and then regression, go to the linear, and then for dependent, where we enter time with average. For independent, where we enter the dose noise exposed, and then we press OK. So this is the square method, linear relationship and square method to find linear regression model. So where we get the variable enter or remove, model summary, ANOVA, and coefficient. So it show that the value that we obtain from the SPSS that can be used to complete a simple linear regression model. Firstly, information about independent and dependent variable. So now we know that the dependent variable is time with average and independent variable is noise exposed. So next, for model summary, it showed that value of R which indicate the simple correlation, and R square which represent the possible of total variation in the value of time with average can be explained by regression line and the value of noise. From the data, we know that the simple linear regression model for this data is with linear relationship. It is because of the value of R is 0.906. The closer value of R to 0, the weaker the linear relationship. And finally, ANOVA show that significant to determine worthy model. In other words, it show whether the value of noise is good predictor of the value of TWA or not. Looking at significant value in this project, show that value of 0.00, which is the value, is less than the alpha, which is 0.05. So the model is set to be significant, which F for 1 and 98 is equal to 0 and P equal to 0. Okay, and then for coefficient, which is the least square method, for 85, for Y is 85.05 plus 0.04x. Since the value of B, the slope the slope value of noise, which is 0.04, the constant line in Y intercept is 85.05. From this coefficient, we know that the graph is actually is positive linear relationship as the value of slope is positive. Then we try to substitute the real value from 100 data into a formula of least square method to prove the SPSS by following this step. So that's all from me. Thank you.
Assalamualaikum and good morning. My name is Imran Muhammad Ghazali and I'm going to explain the hypothesis test for slope beta 1 equal to 1 and beta 1 not equal to 1 by taking 5% level of significance. Okay, this is our sample statistic and test sample. And we can see here, this is the null hypothesis and claim. And this is the formula and that is the data we use. Okay, for the Z critical is 1.645 and this is the formula. We get the value 161.7134 and we can see that in the SPSS the value is the same, so we reject the null hypothesis because the value is more than Z critical. We can conclude that the slope is not equal to 1 because there is enough evidence to support the claim. Okay, next is the hypothesis test for interception beta 0 equal to 0, beta 0 not equal to 0 by taking 5% level of significance. This is the statistic sample and the test sample. The step is the same as before. And this is the formula. We get 13.7657 and in the SPSS we get the same. Since Z test is more than Z critical, we reject the null hypothesis. We can conclude that the intercept is not equal to 0 because there is enough evidence to support the claim. Okay, this is the coefficient of Pearson correlation from SPSS. And this is the tabulate coefficient Pearson correlation. The shape between two variables, since there is correlation exists between it. The Pearson correlation is defined as a measure of strength and reaction to associate that exists between two variables measured on at least an interval scale. The correlation is weak if the Pearson correlation is between plus minus 0.0 to plus minus 0.5, while the correlation is strong if the Pearson correlation is between 0.5 to plus minus 1. The ratio between the time change in second with noise capture has been studied in this project. The value of Pearson correlation is 0.906, which means a strong positive linear correlation. Okay, this is the coefficient of determination. This is the SPSS result. Okay, coefficient of determination is used to measure statistical analysis. When the coefficient is higher, the higher percentage will pass through the line is used as a guideline to calculate the accuracy of the initial statistical analysis. As what we can see from the model summary, R square is equal to 0.821, where 82.1% of the total variation in Y can be explained the linear relationship with X. Okay, this is our SPSS. Okay, now I'm going to show you how to get the hypothesis, to prove the hypothesis. Okay, this is for the beta equal to 1. We get the answer here. And next is beta equal to 0. Okay, this is the answer. We can see the result for SPSS. Okay, next I'm going to show how to find the Pearson correlation. Okay, this is the Pearson correlation. For noise exposed is 1 and for TWA is 0.906. And finally, I'm going to show the linear expression for the linear correlation. Okay, we can see here the R square is equal to 0.821 from the SPSS. Okay, thank you. That's all.
Okay, let's continue to the conclusion. So based on the project that we have made, there are some results presented that can be concluded and can be made from this outcome result, which are there's 100 real data we were collected to complete the data analysis from the United States Department of Labor, Occupational Safety and Health Administration. It has been shown that we are able to learn how to use SPSS software to obtain the result and solve problems involving sampling distributions, hypothesis testing, and simple linear regression for population means. Besides that, we learn how to investigate and examine that the manual calculation accuracy can be proved by using the SPSS software. Therefore, it clearly makes SPSS is a good software can be used by a student or other to analyze data. That's all for our team. Thank you.